Hello, U9s. So this is going to be your speedrun for your chemistry test. I'm going through the checklist that I have made for you. I also have the test in front of me as well to make sure that I cover everything. And this piece of paper here is going to be where I write things. So if you're going to take notes and follow along, you can do this in the PowerPoint that I've made for you with all the information that you need. I'm not going to go through that because it's going to take forever and it's going to be an hour-long video. And I'm sure you don't need that. So I'm just going to go through the checklist and make sure we cover everything in the test. Alright, so first thing is to know how to read a periodic table. For the test, the one you get in your test is going to look something like this. It is colorless in the colors, and if you look at individual elements, you have the atomic number, the atomic mass, the atomic symbol, and then the name of the element underneath. Of course, you'll actually be able to see yours and it won't be fuzzy on camera. So, first things first, you need to know how to read a periodic table. So that's basically if I pull a random element off of the table, that's the element box. Let's go with AU. So that is gold. And the atomic number for gold is 79. And the atomic mass for gold is 196.9. Sorry, yeah, 97. That's not a 7. That's a 7. So you need to be able to tell gold, atomic number for gold, atomic symbol for gold, atomic mass for gold. So here, name of element is here, is the atomic number, this is the atomic symbol, and this the atomic mass. Right? All the things you need to be able to identify all of these things. So we have all of these things for gold, and the element, atomic number, atomic symbol, and atomic mass. Now remember, the atomic number tells you the number of protons and number of electrons. Now remember, atoms like to be balanced. That means they have no charge. So the number of protons is the same as the number of electrons. Okay? Your atomic mass is the number of protons plus the number of neutrons. Okay? Number of protons plus number of neutrons. Atomic mass, number of protons plus the number of neutrons. So because we know what our number of protons is, thanks to the atomic number there, we can work out how many neutrons it has. So that would be 196. Oops. 196 take 79. Okay, I'm sure you guys know all know how to do this math. Okay, so the mass, the number of neutrons is 117 neutrons in gold, right? So you need to know how to work that out. You know the atomic mass is equal to the number of protons plus the number of neutrons, and there is the same number of electrons as there are protons because atoms like to be balanced, all right? So we have covered that, and that. Now we're going to move on to this, where the different subatomic particles are in an atom. So in front of me, I have a drawing of an atom. This here is helium. How do I know it's helium? There are 2 protons in the middle, 2 neutrons in the middle, and 2 electrons on the outside, right? So I need to be able to label this. So I can go, I know that these, even without the minus symbol there, these are electrons, right? These subatomic particles are around the outside of the shell. These 2 here are protons, okay? Because they're in the inside. And these 2 here would be neutrons. Now when it comes to protons and neutrons, if there is no symbol like there is on the electrons, telling you which one's which, you can either A, work it out by looking at the periodic table, finding the element, or B, just assign it either way. Preferably you actually look up what it is on the periodic table, so you know that, hey, there are 2 of these here, they look like they're going to be protons, therefore it is helium. Okay, so you need to be able to label the diagram. And you also need to know that electrons are in the electron cloud or electron shells. They're the same thing, just different ways of phrasing it. Okay, next. So you also need to know how to number the groups and periods on the periodic table. So groups go across and periods go down. Now when we do groups and periods, we ignore these 2 rows down here. We pretend they don't exist. So when I go to label this, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. It is that 1 through to 18 across, starting on the left-hand side and moving towards the right. And then 1, 2, 3, 4, 5, 6, 7, going down. Now, groups that are in the same period, so going across, it means they have the same number of shells. So any element that is in period 5, it means they have 5 electron shells. Any element in period 2 has 2 electron shells. Now, groups, they tell you how many electrons they either give up or take. It actually tells you how many electrons are in their outer shell. So, group 1 has 1 electron. Group 2 has 2 electrons. Now, for your year level, we ignore this little dip here. These are in here are called transition metals. We do not worry about them. They're difficult to work with. And so ignore this entirely. So you go over here. So while this says 13, we also call this group 3. Okay, so we ignore these numbers down here, which means this becomes 3, then 4, 5, 6, 7, and 8. So you can either label it 1 through to 18 or 3, 4, 5, 6, 7, 8. Either one of those labelings will be correct. But whatever labeling you do, you need to make sure you refer to it as that. So if you say you have a question that says, so you have an atom that has 2 electron shells, you will say that it is in period 2. Okay, so we know period 2, 2 electron shells. And say the atom has 2 electrons in its outer shell. So we have to go, so it's in group 2 and has 2 in its outer shell. That means, sorry, it's in period 2 because it has 2 electron shells. And we know it's in group 2 because it has 2 shells in its outer electron. That means it would be beryllium because it's period 2, group 2, beryllium. It's to be that one there. Okay. All right, so this here is an element. Take a moment to pause the video and write down what element you think it is. Count the number of protons, the number of electrons, and the number of neutrons. Your answer should be boron. Alright, so the negative subatomic particle is the electron. The center of the atom, so this part here, that we don't draw a circle around because it's implied that it's in the center, that there is nucleus. Right? The atomic number is, so there's 1, 2, 3, 4, 5. So is 5 because there's 5 protons in the middle there. The atomic mass, we have 5 protons and 5 neutrons. So atomic mass is 10. The name of the atom, well, we named it, it's boron. And what period is the atom in? So how many shells does it have? It has 2 shells, therefore it is in the second period. You do have a question like this in your test. So you need to be able to label the diagram, tell me what's where, these, so you need to know these are the electron shells. You know that this is a nucleus. You know that in your nucleus there are protons and neutrons. In the electron shells, there are electrons. You need to be able to tell me what the atomic number is based on the number of protons that are drawn, and what the atomic mass is by adding the protons and the neutrons together. You should also be able to tell me what period the atom is in by counting how many rings there are. You should be able to tell me what group it's in by counting how many electrons are on the outside. So it's in group 3 because there are 3 electrons in the outermost ring or shell of the atom. So your next question in the test is on isotopes. So it's similar to this. So an isotope has 34 particles in the nucleus and a half-life of 2 days. How many particles are left after 4 days? So that means what this says is every 2 days, this number is cut in half. Okay, so on day 0, that's before any decay starts, we have 34 particles. Now, because it has a half-life of 2 days, we count on day 2. On day 2, so you can half 34. Now, if that means you have to write your working out on your test, that's fine. I don't mind you doing that. So day 2, after 2 days, it's going to have 17 particles. Okay? So after day 4, so another 2 days, because it has a half-life of 2 days, so it's going to take another 2 days to decay to half of its volume. We are going to have 2 into 17, that is 8 with 1 left over. Alright, day 4, we're going to have 8.5 particles left. So, I want to see this working out, and I want to see this. So, starting with day 0, and then however long the length of the half-life is. So, for this one here, it's 2 days. Your half-life might be 1 day, it might be 3 days, but you need to be able to show this working out. So, every time it's decayed by half, that's the next day you write. So day 0 is the first day where no decay has happened. So half-life of 2 days, so we go for day 2, then day 4, and you go on and so forth until you get to how many days it asks you for. So how many particles are left at the day 4? First time round, we drop half, so it's left for 17 particles. Second time, we half that number again, so it's 8.5 particles. If we draw that on a graph, it is going to look something like this. Now, it will never hit 0 because it just keeps dividing until it's smaller, and it will never hit 0. That is something that you need to remember. You also need to remember your nuclear decay. This is a very simple breakdown of nuclear decay. So alpha decay is basically the release of a helium atom. So when that happens and you lose 2 protons and 2 neutrons, so you get a new element forming. So say you had aluminium that went through alpha decay, you'd end up with silicon instead. Okay. Next, you have beta radiation that releases a beta particle, which is similar to an electron. So it releases a negative charge and it becomes unstable. And last, we have gamma radiation. So these release very harmful rays. There is a lot more detail on this in your PowerPoint. Make sure you read it. You need to give 3 examples of evidence. So things you can observe in a chemical change. So these are the different ones you can pick. You need to know at least 4. So you have gas formation, color change, precipitation formation, temperature change, motor displacement, light production, or energy production. Any one of these 4 that you put as an answer will get marked. Please don't leave this question blank because I feel like a lot of you will. You have a table similar to something like this in your test. I'm going to pause the video now and draw this up and fill it in yourself and then check in your answers. Okay? So this should be your final answer. So we have carbon, hydrogen, chlorine, and calcium. The entire table is filled out. I've done a calculation here on the side to figure out the amount of neutrons I had for chlorine. The rest of them I could read off the periodic table. Okay? So this is something that you need to be able to do as well. So you need to know what the law of conservation of mass is. Okay? You wrote this down in class last lesson. Pause the video, write down what it is. Alright, so we have two options here. So the law of conservation of mass / the law of conservation of matter. The top one here is matter. The bottom one here is mass. These both say the same thing. So you can pick which one you prefer to memorize to explain it. So matter is neither created or destroyed, it is only changed. Or mass is neither created or destroyed in any chemical or physical change. Okay? Either one of those is correct. So you will have a question on isotopes. So here are 5 elements. Their atomic symbol has been removed and they've just been placed with a random letter of the alphabet. So we need to look at this and identify which one is an isotope. For that, you need your periodic table. Okay? Now, if you remember what an isotope is, it is an atom with a different mass. So say we have, I don't know, magnesium, okay? Magnesium, the mass for that is 24. Now, isotopes form when we add a neutron. So this here is Mg, and normal magnesium we write as Mg24. Now, if we have an isotope and we add 1 neutron, it now becomes magnesium 25. Okay, so looking back at this here, you need to figure out which number is the atomic symbol and which number is the atomic mass. That's the first thing you do. So you can look at this. So we'll look at E here. Okay, so we have the number 3 and the number 6. So we'll try number 6 first as the atomic number. So find the 6th element. Here is carbon. So we have our 6, but our mass is 12. So obviously it's not carbon. So that means that this number for this is not going to be the atomic number. So we'll put 3 as the atomic number. Find number 3, lithium. And lithium's mass is 6. So therefore, the top here is atomic mass, and this bottom number here is atomic number. Okay, so you need to go through and do that for all of these. Okay. Once you have done so, you can then identify which one of these is an isotope, because it will have the same atomic number as its counterpart, but a different atomic mass. Now, from that information, you should be able to identify what this element is, like we did here. So I know that atomic number 3 and a mass of 6. This element here is lithium. Okay, that's it. So you can go through and identify each of the rest of these elements. Pause the video and do that. So identify the isotope and identify what each of these elements are. Alright, so this should be your final answer. So we have sulfur, we did lithium together, another sulfur, a silicone, and a fluorine. So looking at our periodic table data, you would have noticed that sulfur's regular atomic mass is 32, but the mass for this one here is 33. So this sulfur here is the isotope. Okay, so that is how you work that out with a process of elimination, going through step by step and ordering and sorting each element there. Alright, so you're going to get a question. Will you have to tell me what elements are in this? This is phosphoric acid and this is oxalic acid. You need to be able to tell me what elements are in this. Pause the video, work it out. So this should be your answer. With phosphoric acid, there are 3 hydrogens, so that's H3, 1 phosphorus because it's just the P by itself, and 4 oxygen because the 4 is attached to the O there. For oxalic acid, you should have 2 hydrogen, H2, 2 carbon, C2, and 4 oxygen, O4. Okay, you need to be able to do this. I'm sure you all can. I have full faith in all of your abilities to read and write and count. One more thing I forgot to mention about labeling your periodic table. So not only do you need to label the groups and the periods, you also need to know where the metal staircase is or the metalloid line. So it starts between boron and aluminium, goes down to and across tin, down, across, and down. All the way down to the bottom there. Okay? It looks like that. Any elements on either side of it that directly touch this line are called metalloids. And they have similar properties, and some of them are metals and some of them are non-metals. Okay, so they have properties of both metals and non-metals. So this here is called the metal staircase or the metalloid line. And the last thing you need to know is balancing equations. So this arrow here works like the equal sign. We draw a dotted line in between our two sides. So you have the left side of the equation and the right side of the equation. Then we write down all the different elements that we have. So we have iron, oxygen, and hydrogen, iron, oxygen, and hydrogen. And now we count how many we have on each side. On this side, we have 2 iron, 3 oxygen, and 2 hydrogen. On this side, we have 1 iron, 1 oxygen, and 2 hydrogen. Now this needs to be balanced. So when we are adding numbers, we write them in front as a big number. We do not write them next to it. This little here, these are called subscript. We leave the subscript numbers alone. So if we want 2 iron on this side, we stick a 2 in the front. Now this 2 only affects the iron. The plus symbol in between is like a stop. So it doesn't affect the rest of your equation. So now we have from 1 iron to 2. Okay, so those 2 are balanced. Next, oxygen. We have 3 on this side and only 1 on this side. Now we need 3 oxygen here. We do not write the 3 down here. We write it in front. Now this 3 affects both the hydrogen and the oxygen. We're going to work with the oxygen first. So 3 times 1 is 3. Cross that out. Write a 3. Okay. Next, our hydrogen. 3 times 2 is 6. So this 2 becomes 6. Alright, now our hydrogen on this side needs to be balanced. And our hydrogen is here. So we can just write a 3 in front of it. 3 times 2 is 6. Cross it out. Becomes 6. And now we have a balanced equation. Okay. 2 and 2, 3 and 3, 6 and 6. When you're writing it in your test, make sure you just cross out the number that you are changing. Do not erase it. If you cross it out and I can still read it, I can give you points for that because it shows you're working out. And you may have written the correct number and crossed it out accidentally. You have a butt ton of these to practice up on sector. We're going to go through another one. It's going to be a bit of a harder one. Alright, so if you're going to rewrite your chemical equation that's given to you, make sure you leave space so you can write numbers in front. So, we have a chemical reaction. Dotted line down the middle, listing out all the different elements we have. So we have hydrogen, phosphorus, oxygen, and chlorine. We do not write hydrogen twice, even though it's in 2 separate compounds that are being mixed together. Alright, on the other side, same order. Hydrogen, phosphorus, oxygen, chlorine. Now, make sure you write your symbols properly. So this here is incorrectly written because this is a lowercase c and a lowercase l. So cross it out. Capital C, lowercase l. Same for this one here. Capital C, lowercase l. Alright. Now, these numbers here are for the total number of that element. So for hydrogen, though there's 3 here, there's 1 here as well. So in total, we have 4. Phosphorus, we have 1. Oxygen, we have 4. And chlorine, we have 1. On this side, hydrogen, we have 2. Phosphorus, 1. Oxygen, 1. And chlorine, we have 5. Alright? Now we need to somehow balance this. We'll start with the chlorine first. It doesn't matter which one you start with as long as you end up them being even on both sides. So, chlorine here. 5 on this side, 1 on this side. Easiest thing to do is stick a 5 in front of here. Now we have 5 chlorine. But our hydrogen, we have the 3 plus the 5 is now 8. Okay? Done. Next, we'll go with oxygen. 4 on this side, 0 on this side. So we need 4 on this side here. If we stick a 4 in front here, oxygen changes here to 4. And our hydrogen also changes. So 4 times 2 is 8. So this is no longer 2, it is now 8. Okay? Now, before we move on, let's double check. Hydrogen 8, hydrogen 8. Phosphorus 1, phosphorus 1. Oxygen 4, oxygen 4. Chlorine 5, and chlorine 5. So now we have finished balancing a chemical reaction. It does help if you check after each step to see whether or not you've already balanced it. If you have balanced and you continue going on, you're going to create a big mess. So make sure you check in between. I know we didn't for that one, but we'll do one last one and we'll check in between each step. Alright, last balancing exercise for the video. Draw this setup and write out how many of each element there are on either side of the equation. You should have this answer. Alright, now we're going to go through and balance it. TIs, we're going to leave alone because they're balanced. Cl, we have 4 on this side and 1 on this side. So, 4 in front of here, this becomes 4. Hydrogen also becomes 4. These two are balanced. Hydrogen on this side is 2. This side is 4. We have the 2 here. So we're going to do, to get 4, we times it by 2. So now that becomes 4. Oops, do 1. And now that becomes 2. Okay, check. 1, 1, 4, 4, 4, 4, 2, 2. It's balanced and we are done. Okay? So that's everything you need in your test year 9s. There are plenty of lectures up on Sector, plenty of time to ask questions. If you have them, please ask them. I can't help you if you don't ask them. And let me know if you need any extra information or any extra help with anything. My inbox is open all the time, okay? Ask questions if you need help, please.